Hello again. This is Bradley coming to you from the College of DuPage, and this is being addressed to my Math 2231 students for the spring semester of 2022, and the title of this lecture is Some Additional Course Specifics. As always, please be an attentive listener while watching this video. And recall that previously I sent an earlier video, and I'm not going to be repeating all the stuff. I will repeat some of it, but you should make it a point to watch this previous video if you haven't already, just to make sure you haven't missed anything. In this video that you're currently watching, I do introduce some new material. I talk about the book for the course, I talk about the course content, I show you some faces, mine and others that are important to you, and I will talk some about the modality specifics that we're using in this course initially, and where we hope to go. And I do repeat some information that has been covered earlier, but with more detail, and because it's worth repeating. This is the book we're going to be using. This is the Thomas book. There are additional authors now because Thomas has passed away. This is the 14th edition, and this is what you'll find in the bookstore. Now, in the bookstore, you will have several different ways of purchasing this, but you should realize that this is a book that you might be using for several terms. We have 3 full semesters of engineering calculus, and so if that is your goal, then this, a single book could be purchased to cover all of this stuff. This is the table of contents, and again, this covers on the order of 15 hours of study at the College of DuPage. In this Calculus 1 course, we're going to cover fundamentally the first 5 chapters, and I may do some additional applications, time permitting. So again, we're doing a big bite of the book during this first term. This is the course description of the College of DuPage. This is what you signed up for. I'll read it. This is the first calculus course for students majoring in science, technology, engineering, and mathematics. There is a different course for students who are studying business, and if you want to talk to me about that, you should, because it is a different course. I have taught it as well, and you want to make sure you're doing the right course. In this course, the topics will include lines, circles, functions, limits, continuity, the derivative, rules for differentiation of algebraic, trigonometric, and transcendental functions, related rates, mean value theorem, optimization and curve sketching, differentials, Newton's method, antiderivatives and integration, and the fundamental theorem of calculus, among other things. We have a whole bunch of objectives in this course. It is a 5 semester hour course. So we'll start talking about the use of the definition of a limit of a function. We'll evaluate limits graphically and numerically. We'll evaluate one-sided limits. We'll talk about continuity of a function at a point and over an interval. We'll find the derivative of a function using the limit definition and determine the differentiability of a function at a point and over an interval. We'll talk about the intermediate value theorem, and we'll have rules for differentiation to find the derivative of a function, including rules called product, quotient, and chain rules. We'll learn about differentiating implicitly. We'll use these derivatives in geometry and other applications involving rates of change. We'll determine higher order derivatives when have applications of these to linear motion. We'll determine what's called the differential of a function and use it in error analysis, also in approximation. We'll find the location and type of all relative and absolute extrema of a function using the first and second derivatives. We use derivatives to determine where a function is increasing, decreasing, where its graph is concave up, and where its graph is concave down. We'll use a theorem known as the extreme value theorem. We'll also talk about Rolle's theorem and the mean value theorem. We'll determine the limit of a function at infinity, and we'll also use a technique known as L'Hopital's rule to evaluate limits for indeterminate forms. And we will evaluate limits having these indeterminate forms. The list goes on and on. We will compare and contrast relative rates of growth. We'll locate all, if any, vertical, horizontal, and slant asymptotes of a graph of a function. We'll construct the graph of a function by locating all intercepts, asymptotes, relative extreme points, and by determining concavity over the domain of the function. We'll solve optimization problems, including applications of those. We'll determine the approximate zeros of a function using Newton's method, solve problems known as related rates problems, including applications. We'll talk about antiderivatives of a function. We will solve a separable differential equation and an initial value problem. We'll estimate a definite integral using a Riemann sum, and we'll define and evaluate definite integrals by taking the limit of a Riemann sum. We'll use the fundamental theorem of calculus to evaluate definite integrals and use techniques known as substitution to determine the value of definite and indefinite integrals. And we'll understand the properties of definite and indefinite integrals, and we'll determine the mean value of a continuous function over a closed interval. We'll define the exponential and logarithmic functions, and we'll graph them, and we'll simplify them using properties of those. We'll also learn about the calculus of them. We will learn about differentiating logarithmic and exponential functions and integrating logarithm and exponential functions for various bases. We will learn a technique known as logarithmic differentiation. We'll evaluate integrals that result in logarithmic functions, and we'll evaluate expressions involving other transcendental functions called inverse trigonometric functions, and we will also differentiate expressions involving these inverse trigonometric functions and trigonometric functions. A lot to do in one term, but it is a 5-hour course. We also have a topical outline. We may or may not follow this order, but again, this is another kind of checklist. We won't do a lot of review. We'll tend to do review within the context, but we'll start with a very, very, very limited review. Calculus is the study of limits and continuity, so we will talk about those. And then we will talk about a very important limit called the derivative. And we will talk about important applications of that limit called a derivative. We'll continue talking about those applications, and then we'll talk about a second very important limit known as a definite integral. And we'll do many things related to that as well. Again, a lot of material in a 5-hour course. I told you I'd show you some pictures. This is a picture of me. My given name is Patrick James Bradley. My friends call me Jim. You can call me Professor Bradley if you want, or you can call me Jim. I think we should be friends as well as being instructor and student. I look more or less like this, except my hair is much longer now, and I typically wear a mask. There's where I sometimes am, but way more often I'm in the Learning Commons, which is SRC 2102. And these are the office hours I published earlier. So I'm going to be in there Monday through Friday, 8 to 8:50, and Monday through Friday I will have virtual office hours in the evening as well. I published those earlier. I am supporting guided study groups. I talked about these earlier, but this is a wonderful thing because we have someone who's getting paid to provide you some guidance, and you can get together. This is actually a picture of one of my guided study groups back when we were doing everything face-to-face. Our guided study group leader for both courses, both of the Calculus 1 courses that I'm teaching, is a young woman known as Linda Shaw. And here you see a picture of Linda Shaw and her dog, Seven. Linda is very great at math. She's just short of finishing her master's degree, and she's doing some outreach to high school math teams in addition to her full-time job. She's the ranking STEM member in the Learning Commons, and she is known to be great at tutoring and teaching as well. I've worked with Linda a number of times, and we're blessed to have Linda and her dog Seven helping us in our Math 2231 guided study groups this term. Not only does her dog love her, but her students tend to like her as well. And I've mentioned before the Math Assistance area. They're open over 70 hours a week, both virtually and face-to-face. There's a lot of expertise here. This is where I tend to hang out when I am not teaching. I know I said this stuff before, but I'll say some additional information now. You see, it's not just math assistance, but you can get help in your math, physics, chemistry, and actually some of your computer science courses. There is going to be a one-button access from from Blackboard whenever we finally get Blackboard back, and so it's a very convenient way for you to get face-to-face and online help in those disciplines. They have many functions where you can just ask questions by email and some review material. So this is a great resource for you, and I will be posting these flyers somewhere else so you can look at them there as well. Now I am teaching two sections of this. One is a VCM, and the other one was supposed to be face-to-face. So I'm going to say a few words about modalities. So my goal is to try to run both classes as one as much as possible. For example, this email is going out to both of those classes. There's no fundamental difference. And what we will do is we will pivot according to the needs of your situations and the needs of the college. And I'm comfortable either way. I've done this course face-to-face, I've done it VCM, and I've done it completely online. But as you know, we're starting out this term in an online mode with the goal of, at least for the class that is listed as face-to-face, my goal is to change to face-to-face when I can. But I'm also comfortable doing things the other way. So either way, things will be fine. I will be fine and you will be fine. Either way, teaching and learning will continue unabated, grades will be earned and rendered, and educational goals need not be deferred. This is some important stuff. Now, I'm emphasizing grades, and I'm talking about these again. I already talked about this, but I want you to understand this is a 5-hour course. So this counts more for your grade point average than the 1-hour PE course you might be taking or a 2-hour other course. It's 5 full semester hours. Moreover, this is a gateway course. You have to get a C or better in this course to progress. So this is an important course. Again, we will have 3 elements. There'll be what I call low stakes assessments, which will be mostly learning exercises. And that'll be 1/3 of your grade coming from the low stakes assessments. We will have a midterm exam and a comprehensive final exam. I will take these 300 points and use a grading scale. And it's not a situation where there's extra credit. I'm pretty much going to say you had 300 points to earn, and where did you land? And again, even though I talk about beyond a wholesome discipline, I strive to render grades gently. I'm not doing anyone a favor if I give you a grade in Calculus 1 saying that you understand the material and you go into Calculus 2 and don't understand it. So there is significant measure of wholesome discipline here. So really strive to do well in this course. Again, a 5-hour course, a 5-hour gateway course. In closing, now more than ever, time is precious. Each day must count. Do the math. It will make you strong. And now more than ever, take care of yourself. Self-care is important, and of each other, because we're all in this together. God bless you all. More later and soon.